So I'm Daniel Leavitt. I'm one of the developer relations engineers at the SWE Foundation. But that said, I also work very closely with the Walrus team and the Walrus product. So I'm very familiar with developing on both SWE and Walrus. And today I'll give you guys an overview of what Walrus is and then answer some of the questions you guys have pre-submitted and questions you may still have. So I'm not going to go through this completely. But I'll just briefly explain like why we have Walrus, like why we wanted to build it. So like, for example, we still see a huge need for decentralized data on the internet in both Web3 and Web2. Like, for example, like we have like decentralized apps, right? And these are apps that use some set of smart contracts for their backend. But the issue is that most of these apps are hosted on centralized servers. So if the website of the decentralized app were to go down, most users wouldn't have the ability to use that app anymore. So essentially, their funds are lost. And I know that technically you would still be able to access the smart contracts, but we can't expect most users to have the technical know-how to do that. So if the websites are down, that essentially means that most users won't be able to access it. And it's the same with NFTs, for example. NFTs is has huge potential in the Web3 and Web2 world, but you could wake up one day having paid for a lot of money for an NFT, and then you wake up and the image is not hosted anymore. And that's because usually the image is hosted in some sort of centralized server. So if the person hosting that image decides to take it down or that server goes down, you won't have that image anymore. And you may have a copy of that image, but if you ever wanted to sell the NFT or just show it off to other people, they may not be able to see it anymore. And these aren't just issues in Web3. We see this in general internet apps as well. Like, we're generating so much data, especially now with AI. We have so much data, and data is so valuable. And when we are generating stuff, posting information, we don't really own this data on the internet. So we have to put a lot of trust into those that are holding our data. I mean, you guys all work on blockchain, so you understand like being trustless and like not having to rely on central agencies, and we want to make sure that the data is also decentralized, because data is a huge part of the internet, besides all of the like computation and logic that's happening. So this is why, so basically we see blockchain, the goal of blockchain is to decentralize the internet. And we see Walrus as the next step in decentralizing this internet. So we built SWE to be the global coordination layer. It's be the computation layer, so it has all the logic and is a way for people to own their assets on the internet. And you guys are all familiar with SWE, so I won't go into SWE, but we see that, like we said, when you build apps or you're managing people's data, you still need a decentralized way to do this. Like, the decentralized internet's going to be full of videos, images, long form texts, all this stuff, even like L2 archival data or stuff like that. And we need a decentralized place to store all of this data, and that's where Walrus comes in. So Walrus is a decentralized storage network that allows you to store gigabytes of data at reasonable cost. And the Walrus team focused a lot on making sure that the network was resilient, which I will go into later, as well as very high performant. And because it uses SWE, we also get a lot more programmability out of it than we do with existing decentralized storage networks. Yeah, so I'm going to go over an overview of what Walrus is. And this may answer some of your questions, but I'm going to retouch this all at the end when I go over the questions that you guys have pre-submitted. But a lot of people ask, like, so on other decentralized storage networks, when you upload data, that data is typically replicated at every single node. So every node is holding the same amount of data. So if you upload a gigabyte, that gigabyte's replicated like almost per node in some cases. But with Walrus, we have a constant replication factor, and that's around 4 to 5x. So when you upload a blob to Walrus, that blob will be replicated 4 to 5 times. And then once it's replicated, it's encoded using a novel erasure coding algorithm, which basically means that when you encode it with this algorithm, you can split up in the data into multiple pieces and then distribute that among the network. And if one of the nodes goes down that holds a few pieces of that data, all of the other nodes can work together to replicate, to retrieve or like rebuild the lost data using the other parts. So all of the parts kind of have some sort of data regarding other pieces of the data. Yeah, so, but essentially since we have a constant factor and a very low factor, 4 to 5x, this allows us to be very cost effective. So we're not like having to store this data on every network, which is can cost a lot of money. And in addition, that allows us to be a lot more scalable because we're not, every time a node joins, we're not forcing them or requiring them to store every piece of data. We're actually increasing the performance and capacity the more we add more nodes. That said, resiliency is one of the biggest factors of Walrus. We want Walrus to be resilient because we want people to store all kinds of data on Walrus, which includes like more sensitive data or very important data that needs to stay available to everyone. So this is why we have a high focus on resilience. So I think it's really impressive that 2/3 of the network can go down and you'd still be able to retrieve the data that you stored on Walrus. So this uses the erasure coding algorithms that I talked about a little bit ago. So if like nodes go down, the other nodes can work together to retrieve this lost data. And like I said, SWI is used as the coordination layer, and the Walrus team used SWI for a few reasons. SWI is very performant, as you all know. Like SWI is the fastest blockchain out there. And because Walrus uses SWI as a coordination layer for managing all of the metadata and payments and stuff, Walrus gets to be really fast. Like if Walrus was using another chain, it would have to rely on that chain for the speed. So that's one reason why we chose SWI. And then another reason is we didn't want to like create a new version of SWI or like our own blockchain. So that way the Walrus core team can focus purely on the data storage part, and they can like focus on this like erasure coding algorithm and making it as cost effective, but also as robust and resilient as possible. And I think the most important aspect of using SWI is that for the first time, storage and like availability and storage capacity can now be tokenized as an asset on SWI. So there's a lot of potential use cases that come out of this. Like you can imagine smart contract-based storage marketplaces, rentals, as well as integrations with either like DeFi or oracles and stuff like that. Really the possibilities are limitless now that we can have better access to data capacity with SWI. And you've probably all seen that like we launched mainnet last week. So Walrus is now live on mainnet. We have the Walrus token, which was deployed along with Walrus mainnet. So the token now lives on SWI, and you use the Walrus token for payments as well as staking, governance, and stuff like that. And another note is that the network like also has methods where you are able to, like the nodes are able to basically check each other to make sure the data that they're holding is correct and secure and still there as well. Okay, so that's a high overview, and I'm sure that's already answered some of your questions, but let me see. Yeah, so this is, a lot of people ask, like almost all apps that deal with data have to deal with privacy in one way or another. And so that's probably the biggest question we get when people want to build on Walrus is, what about privacy? So everything that you store on Walrus is public by default. So So like as soon as a blob is uploaded to Walrus, anyone has the ability to download and read that piece of data. So if you want to make sure that only certain people can access that data, you need to encrypt it on your side before you upload it to Walrus. And we will be providing some features, some products that you can use that integrate with both SWE and Walrus to encrypt some sort of data and use like aspects of SWE for the access control, such as like certain addresses, or you have to pay first or stuff like that. But this does always have to be done before you upload to Walrus. And this kind of stays with the overall theme of Walrus. Is Walrus was designed to be the base layer for decentralized data, but it's supposed to be as compatible as possible with any layer that someone wants to build on top. For example, like if you wanted to build an encryption service or you had very specific needs for encryption, you can build that on your own and you don't have to conflict with any existing services that Walrus provides. And it's the same with caches. For example, if you need like higher performant reading, you can use caches, or even like streaming. Like I know one of you was asking about whether like you can stream data in, like whether you can do like a partial read of a large blob. So this isn't supported on Walrus by default, but anyone has the ability to build a layer on top of Walrus that does support it and then provides this as a service to the developers that build with Walrus. So that's kind of like the general theme, is that Walrus is kept simple, and that's on purpose because we want the community and all the developers in the community to build services on top of Walrus for developers to use. And I think I'm going to take this time to answer some of the questions we have, because I'm sure you're all familiar with this and it's more important to address the questions. So I'm going to just go through the list of the questions we have that were pre-submitted. And some of these will be repeated, but like the first question is, how does Walrus handle storing blobs? And how is each blob replicated across nodes? So I brought this up already, but oh yeah. Harry, do you have a question?
Yeah, I also want to ask the team that please feel free to raise your hand and ask the question. And
Yeah.
like my question is like, can you please explain on the eraser coding,
Mm-hmm.
how it is like, what's the algorithm? Can you please explain in short?
Yeah. So I can't go like into super detail, but we do have more information on the white paper, which I can actually share with you guys here. So the Walrus white paper, the QR code on the left, will have more information about this. But basically, yeah, it's encoded, so it's padded with more information, and then all of those pieces of data are distributed around the network, and it's essentially distributed and encoded in a way that you can recover missing pieces using the pieces you already have. So maybe if you want to look more into that, you can read the white paper about this, and then if you have any further questions, I'd be happy to answer those after that as well. And like I can forward that to the core team as well.
Thank you, Daniel.
Yep. But yeah, so related to that, every piece of data is stored with a constant replication factor, and it uses the erasure encoding to do this. And then there's a related question. I saw someone was uploading a very small file onto Walrus, like just a few bytes. But they noticed that unencoded, it was 14 bytes, but then when it was encoded, it went all the way up to 63 megabytes. And the reason for this is Walrus, when it encodes the data, there's a constant overhead, which is approximately 63 megabytes. So if you store anything on Walrus that is smaller than a few megabytes, you'll basically your price will be dominated by the constant overhead encoding size, which is around 63 megabytes. So that's why it's recommended that you're storing data that's bigger or around that size. If you're storing bytes of data, then it's recommended that you don't use Walrus. I would be curious on the use case, but I would suggest, like, if you have smaller data or data that needs to be read more often or like changed very quickly, then I would recommend using Sui, because Sui can handle like the smaller, like if you're dealing with just a few bytes, Sui can handle that very efficiently, and it's much cheaper for you as developers. Yeah, so that is one thing that we. Oh yeah, go ahead, BJ.
Sorry, Daniel. So for NFTs, you said earlier, right? Then Sui is better because of the size.
Yeah, so for the NFT, like if it's a video or a picture, I would recommend storing the picture on Walrus. Even though the picture may not be like very, very big, but it's at least going to be like hopefully like kilobytes or megabytes. And that's better to be stored on Walrus. But like if you, like, let's say you have a profile and all of the metadata, such as like a user, like let's say it's a game profile, and the experience level that player has, or maybe the inventory of that player, it would be better stored on Sui than Walrus. Especially because on Walrus, all of the content is addressed by that specific data. Like when I upload an image to Walrus, a blob ID is generated based on the content. So if I change the content of that image, for example, that's going to be a new blob. And so you can't like update existing blobs and keep the same ID. So it's not like Sui in that sense. So like a lot of people try to store like usernames or user data on Walrus, when in reality, this would probably be better on Sui, because then you can update it without having to manage all of the changing IDs, and it's much cheaper as well. Yeah. Let's see here.
So Suyog or somebody else, Sagar, if from our projects, because you guys know all of it, like especially Vendetta, have we used Sui and Walrus together, like the way Daniel is explaining? Or is there a use case for that?
Not right now. So we are planning to use Walrus like for player images.
Mm-hmm.
Not right now. Currently, it's all stored on Sui.
Gotcha. Okay. Yeah. So like I think images is a great example of something that's big enough to be stored on Walrus for sure. Yeah. And then so I'm just going to continue down the questions I have. So I kind of already brought this up. So like whenever a node fails, the other nodes are able to recover these blobs based off the erasure coding algorithm. And like I said earlier, 2/3 of the nodes can go down and you'd still be able to retrieve your data. And then some of you have been asking about like the blob attributes that we have. So when you upload a blob, you also are able to like set some metadata along for that specific blob. And you guys are asking like, what are practical like use cases for this? I think there's a lot of potential use cases, but like the most basic one would be putting in the metadata the type of content that blob is. So like for example, if you're uploading a video to Walrus, you could even say like this content type is an MP4, for example. So then you can let whoever wants to read that data, when they read the blob, without that metadata, they won't know what it is, and they'll have to kind of guess or figure out what that type is. But if you tell that person or browser that it's a video, then they'll be able to support this dynamically. So like if you are able, like if you set the attribute to a video, and let's say you're looking at the Walrus Explorer, that Walrus Explorer could use that metadata to render the video right away rather than have to like guess or not be able to know what type of blob it is. And then you would have to just download it and figure it out yourself. But that's just one use case. Like there's plenty of use cases, but it's kind of like the rest is kind of up to you, like what kind of attributes you want to be able to read along with the data. What is useful for you to know. Yeah. And then let me see here. And then, yeah, so I mentioned earlier, so Walrus doesn't support any partial retrieval of large blobs or anything like that. When you read a blob, you have to read the whole blob. But that said, like I said, Walrus is designed for others to build layers on top of it. Like if you want to build a CDN layer or a cache layer, so then you can read data more quickly, then this is an opportunity, I think a great opportunity for developers, especially since the ecosystem is so young. I think there's going to be a lot of need for layers on top. Like if someone wanted to do video streaming, or there's so many use cases where you could potentially provide infrastructure and a service to the other developers that want to build on top of Walrus. Let's see. Yeah, so one question is, if a storage node with limited storage capacity gets selected for the next epoch, how does Walrus ensure that it can scale up in time to handle the transfers and the increased storage requirements? So the selection of the next committee of the next epoch is selected like well in advance of the current epoch. I believe that the process starts halfway through the current epoch. An epoch is how long like each, it's basically how long each round of Walrus will go. So every epoch, there's a new set of nodes that will be storing this data. And so there's ample time is given for these nodes to retrieve or provision more data if they need to. So like right now, like they have like days to do this. Yeah, so another feature that we support on Walrus is deleting blobs. But I will say that the deleting feature is mainly to clear up space that you're renting out, or maybe like stop paying for space that you don't want to pay for anymore. But it's not, there's no guarantee that when you delete data off Walrus, that it will be completely removed from every single node on the network. Like we can't control what data the nodes actually store. So, but that said, if a node is acting accordingly and a blob is deleted, that means they're no longer going to be paid for storing that blob. So there's really no incentive for them to store it. But that said, the node could technically still store that blob. So there's no guarantees with deleting that your data will be cleared, but it's a guarantee that you won't have to pay for that data anymore. And I had a question, like it says, in the future, will there be a way to read Walrus stored data directly within a SWI smart contract? And there's nothing like this planned, but I would I'm wondering like what use case whoever asked this question like sees the need for this, because I think like I said earlier, there is a relationship whether there should be a question of whether like, should I store this on SWI or should I store this on Walrus? And if you need something in a SWI smart contract, then it might be possible that you should actually just store that data on SWI. But I'd be curious to hear like any sort of use cases where you have big amounts of data that you would want to be readable in a smart contract. So if you ask that question or you have any ideas, like feel free to.
Yeah, so Daniel, so that question was like more of a let's say we are creating a NFT contract and the images are being stored on Walrus.
Yep.
So I just wanted to know, like, if just putting blob ID, like the Walrus blob ID on the NFT contract image URL field, will that be will that be possible that the Sui network will just display the blob ID from the Walrus as an image, maybe in future?
Yeah. So if you have an NFT, you store the image on Walrus, and you in the URL you have the blob ID. So
Yep.
right now you need to, if you just put the blob ID in there, that wouldn't work. You would have to use one of the aggregators or set up your own aggregator to read the blob ID and then set that URL in the URL attribute for the NFT. So currently there is no standard. When, let's say, the Sui explorers read the data and use the display standard, they're going to read the image URL and fetch that. Right now, you have to provide the URL. You can't just provide the blob ID. In the future, this may be the case that we want to provide a blob ID, and then whatever app that's trying to display that image chooses the aggregator URL that they want to use. But right now, this responsibility is on the NFT itself. So it's going to have to choose an aggregator. And again, this is a service, I could imagine a service being produced where there's an aggregator, a layer between the aggregators and the NFTs that randomly shuffles through the aggregators to ensure that the image is always rendered. So if an aggregator URL goes down, it switches to one that's still up. But I hope that answers your question.
Yeah.
Okay.
Thank you.
Yeah. Do you guys have any other questions? If you want, you can put them in the chat or just unmute or raise your hand, or I can.
Yeah, also one question, Daniel. So
Yeah.
Deleting a blob, will that also delete the storage in the Sui, or it just deletes the blob from Walrus?
It deletes the blob. I don't think it will delete the blob object, and that's because the blob objects are owned objects. So I think whoever owns that blob has the ability to delete that object, but it can't be done by the network automatically.
No, I mean there is a separate storage object too, right? While storing the blob in the Walrus, we need to set up a storage object.
Oh, yes, I see what you mean. Yeah, so there's storage and then the blobs. So
yeah,
I'd have to check on this to make sure, but let me see if the doc says anything on this. So I think it may be the case that you you can, when you delete the blob, you can reuse the storage resource. I don't know if it destroys the resource or not. I'd have to check with that, but I can get back to you on that one. Let me write that down here.
Okay.
I would assume that the storage resource isn't deleted because technically your storage resource could be way bigger than the blob, and you have to specify only the blob when you delete it. So it wouldn't make sense for it to destroy the whole storage resource. Yeah, but I can double check.
Yeah, also one question, Daniel.
Yeah,
I think Busy is also raising his hand. Maybe Busy, you can go.
Yeah, quickly. So I think we had talked about this before. When when we create a website with Walrus, it still has that Walrus extension. Do you have any other update on this, redirecting it to a regular Web 2 URL kind of?
Yeah. So right now, this isn't possible, unfortunately. So right now, at least with our portals, you wouldn't be able to do this. Yeah. So, and for those of you who don't know, Walrus sites, what we're talking about is Walrus site is a product that allows you to deploy websites and host them on Walrus. So this like addresses the problem we saw earlier with these decentralized apps that could go down because they're hosted in a centralized way. But as of right now, like our portal is wall.app. So like our docs page is hosted at docs.wall.app. And as a developer, I don't think you'll be able to like redirect to a different site. But that said, like hopefully there will be plans for this soon. I think the Inoki team is planning on adding additional tools on top of Walrus sites. And I think one of those tools will be using your own domains, like your own Web2 domains. And I think Inoki, I'm not sure what their like official timeline is, but I think that they should have like some of these features up and running like within like the next 6 months or so. So like you should be able to like host websites from the Inoki platform and stuff like that.
Yep. Thank you.
Yep. Yeah, but Walrus sites I think is a really cool product, and I think it'll be really nice. And there's even, I'm sure like you guys have heard of like Flatland. There's a demo NFT collection that we have that uses Walrus sites. So every time an NFT is minted, we also create a new Walrus site that is owned or that is specific to that NFT and like uses the NFT's metadata to customize the site for that NFT. So that's just like one example. And you could potentially even make it so that the owner of that NFT has the ability to edit the website itself, because every time you deploy a Walrus site, there's a sweet object that's created that represents ownership and the ability to edit it. And you could have that object nested in the NFT itself so that the owner of the NFT basically has full control over that NFT site. Yeah.
So, Ujjwal or Suyog, this is what I was thinking for Vendetta. When we do mint the NFTs, could we automatically create a Walrus website for those NFTs?
Yeah.
Would that be a good feature?
Are you asking me?
No, I'm asking Ujjwal and Suyog.
Sure.
Yeah, I think we have like already one example that just Daniel mentioned right before this about Flatland. So yeah, we can think about it. So that's possible.
Yeah, because that will give additional kind of value to the NFT owner, right? And it would be a good experiment for us to also see how we can create more value through the technology that Walrus already provides for the NFTs.
Yeah, and I think Flatland is open source as well. So you can like use that as a reference to see how it's done. But yeah, I definitely would like add like more utility to that NFT rather than just like storing some metadata. And then it essentially like more decentralizes gaming. So then like as long as you own this NFT, you should like have access to the game. Like the gaming site doesn't ever can't go down if like you have it on Walrus.
Yeah, and especially now Vendetta is an on-chain game, right? On Sui. So that just adds to the whole ecosystem value.
Yeah.
To have everything on there and never go down, so to speak.
Also, Daniel, one question regarding the storage deletion. Like let's say if I paid paid wall token for like 14 epochs, and I delete my like storage at let's say at around 7 epoch, then will I get some refund for like, because I have paid the wall token for 14 and I am like deleting it at 7. So is there any possibility that I'll get refund, or how does that work?
I'm pretty sure since you pay up front, and I don't think there is any refunding with the deletion. So
Okay.
it's so it's mainly just to clear up the storage, but then you don't like get that back. But you
So
could essentially, I think there's ways. I don't know if this is built in, but you could still technically use that resource. I think like you paid for that storage, so you still have access to it. You could like technically, I think, still use that resource until the epoch that you've paid for with other data if you need it.
okay.
Yeah.
Any questions from any guys?
I can also go over like, so we launched mainnet. I can go over like the developer resources as well. Let me see. Yeah, so like we just launched mainnet last week, and we also have some different ways to interact with Walrus. Like we have the Walrus CLI, and you can use this to query like the network information, or actually like read and write blobs to the network, as well as like query the blobs. And you can also use the CLI to set up your own aggregators and publishers. Like if you guys have been building on Walrus on testnet, we've had a list of free publishers and aggregators that allow you to basically write to the network for free and read that data for free. But for mainnet, we don't provide like free publishers and aggregators. So if you want to have an HTTP API that interacts with like your front end, for example, to let your users upload data, or for you to upload your user data on the back end, you would have to set up your own aggregator or publisher. And you can set this up using the Walrus CLI. And in addition to that, we also have some SDKs like a TypeScript and a Rust SDK. The TypeScript SDK is live. I think the Rust SDK will become live very soon. And what the TypeScript SDK does, it's not really meant for being used on the client for uploading directly to Walrus or reading directly from Walrus. It's the purpose of the SDK is to help you set up your own publishers or aggregators on the back end, so that you can use them via your front end. And the reason is because writing a blob requires a lot of handshakes back and forth between the network and the client or the backend that's publishing this data. So it's better if that's handled on the back end, and you can like customize what you want to have happen, and like the logic or the requirements for uploading data, and then you use it on the front end. And again, like I imagine as the network matures, there's going to be more of these publishers as a service that allow you to just plug into their backend, and they have like custom logic and features that you'll be able to use if you use their services. Yeah. But more information can be found on the SWE TypeScript docs page, as well as like the docs page for Walrus. I don't know if I have a link for, oh yeah, so this Walrus, actually this might be the old doc. Let me send the link here. Okay, so this is the new link for the docs page, and it should have everything you need here. And then let me find the link to the SDK docs as well. Okay, yeah, so this is the link for the Walrus SDK docs that are in TypeScript.
Yeah, thanks, Daniel. Also, Daniel, one question was, since the blobs are encoded into primary and secondary server, right?
Mhm.
How are primary and secondary server being distributed across multiple nodes? Like, do you have like some example or maybe some high level that you can enlighten us?
Yeah, so from what I understand, a primary and secondary shards are sent in pairs. So like I don't exactly know what the relationship between the pairs of primary and secondary shards. If you have like a specific question, I can ask the core team, the people who like actually design the system, for more details. But yeah, I can't really speak to like the relationship between those two.
Okay, maybe I'll just post a question in Telegram later.
Yeah, yeah. If you're on the Telegram, I can forward that to the team as well. Yeah.
That would be great.